Okay, guys. All right. Now that you have x as a function of time, okay, and you have y as a function of time, I can basically find y as a function of x. Can someone tell me? Can someone think of a way to capture basically y as a function of x? I think from here, good. I can say t is equal to how much? X of t divided by v0 cosine theta, right? Where theta is the actual launch angle. So I replace that t into here, and then I'm going to be able to find y as a function of x, right? So let's do that. So basically, I have now y is function of x is equal to minus g over 2 t squared. So t is equal to x divided by v0 cosine theta square plus v0 sine theta multiplied by t, which is equal to x divided by v0 cosine theta. Okay. Okay, so that is going to be equal to minus g over 2 v0 squared cosine squared theta x squared plus v0 and v0 will cancel out. Sine theta divided by cosine theta is equal to tangent theta x. So this is your y as a function of x. And you can see basically that this is clearly a projectile movement, right? Because you have y is equal to minus gx squared plus this guy times x. So you know it's going to be basically curved like that. So whenever that the x squared term is actually negative, then your parabola is actually down. And if this guy was positive, then your projectile will actually be up. Okay, now I have a question, like, you know, if I have a projectile right now, how can I find, let's say you have actually a projectile like this, how can you find, for example, the time where you reach the top? And then how can I actually find the actual range of this guy, given some initial velocity, and then given some launch angle theta? How can I find first the time here? Let's actually call this guy, let's call this T1. How can I find T1?
Vy
equals 0.
Exactly. So we're going to use Vy is equal to 0. And then we already have Vy, right? What is Vy? Vy is here. Was good. So let me rewrite that over here. Very good. So we have Vy, which was equal to minus gt plus v0 sine theta. So Vy at time t1 is equal to 0, is equal to minus g t1 plus v0 sine theta. Okay, so what is t1 in that case? Then t1 is going to be equal to how much? v0 sine theta over g. Okay, how can I find now the actual height, the maximum height of a projectile? How can I do that?
X at t1.
No.
No, sorry, y at t1. Y at t1. Sorry.
We'll simply find y of t1, right? And you already have y of t. I'm going to rewrite that for you guys because you don't have the notes. So t squared plus v0 sine theta. So this is y as a function of time, which I had earlier. Okay. So what is y of t1? So y of t1 is going to be equal to minus g over 2 t1 squared. So v0 sine theta over g squared plus v0 sine theta multiplied by v0 sine theta over g. Okay, so you can see you have v0 square sine theta over g. مظبوط. هون you have the same thing, right? And basically here you have g squared on the bottom and then you have g on top. So it will be v0 squared. So the first one is going to be minus v0 squared sine squared theta over 2g. And then here you're going to have v0 squared sine squared theta over g. So it's like you have minus 1/2 plus 1 is going to be equal to 1/2, right? Right? So that will be equal to how much? v0 squared sine squared theta over 2g. So let's call this as h. So this is the maximum height of a projectile. Any questions on that, guys? Now, can someone tell me what should be my angle, right, in order for me to have the maximum height?
90.
90 exactly. Why?
لأنه sin 91 وساين varies بين 0 و 1. maximum value is 1 so that equal pi over 2 تكون maximum.
Exactly. So now that would be okay. Let us now work out the maximum distance, right? So now we looked at the maximum height. Let's look at the maximum distance that a projectile can actually travel. So let's look into that, right? So we said time here is equal to 0, مظبوط? And now we said this is your velocity vector v0, and then we said the launch angle is theta, right? Let us actually now consider that distance, right? Or the range. This is called the range of the projectile. How can you find the range of the projectile? We said this is time t1 مظبوط. And this is your x, and this is your y.
For y.
Can someone tell me what is my range?
Y equals to 0. We get t, then we replace an x.
Okay, so there are definitely multiple ways. So one way we can do is we can write y is equal to 0, and then we can find the time. Or maybe we know that this is symmetrical. So it's going to be what is time here, what time it will actually be here, provided that you are starting on the same, or you would be at the same level. I think here you would be at 2t1, check.
اوكي دكتور خط جيرس بدنا إياه، مش الديستنس covered.
Yeah, the distance covered. How can I find the distance covered?
الديستنس covered مش جيلسي، هي بارمي كيرف، يعني مش عم نعملها مش عم نقيسها جيلسي.
No, we are measure. It's very difficult to actually measure the length of the projectile along its path.
اوكي.
It's very difficult to actually do that. But how about this distance right here? So that distance, we know the time here is going to be 2t1. How can I find the range right now? Can someone quickly tell me?
X معنى الأكس.
Exactly. So this r is equal to what? X at what?
At time 2t1.
Definitely. Do you guys all agree on that, or are we moving too fast? If you guys feel like we're going fast, we can spend more time on this, and then I don't mind at all. If anyone feels like you need more time on this, obviously you have the lecture posted on YouTube. You'll be able to watch it again and again and again. But if you have questions now, by any means, I would love to get all your questions, and then I'm very happy to answer any questions that you may have. Okay, what is x at time 2t1? What was x of t? So x of t
minus jt squared over 2.
Yeah, but what was x of t was equal to v0 مظبوط v0 cosine theta t, right? So x at 2t1 is going to be equal to v0 cosine theta. What was t in this case? 2, right? 2 v0 sine theta over g. All agreed here? Right? So it's going to be 2 v0 squared. What is cosine? Okay, cosine theta times sine theta over g. So this is the projectile range. Now, let me ask you guys a question. Can someone tell me what angle will actually give you the longest range?
45.
Why?
Because if we solve for it to be maximum, يعني بدنا numerator to be maximum, يعني cosine theta sin theta maximum. In order for them to be maximum, تكون 45.
Why is that? Like, how can you quickly tell it's 45? Why not 30?
دكتور بس في سؤال.
Yeah, sure.
2 كوساين ثيتا ساين ثيتا مش هي ساين 2 ثيتا؟
Yes.
يعني ساين 2 ثيتا تكون ماكسيموم بقى تكون انجل
Exactly. What is the maximum value for sine 2 theta, guys?
باي اوفر 4 يعني بقى تكون ثيتا.
What is the maximum value for sine 2 theta?
باي اوفر 2.
No, the maximum value for the actual sine 2 theta.
1.
اوكي maximum اوكي 1.
So 2 theta is equal to how much? Pi over 2, right? So theta is equal to pi over 4, right? Which is 45 degrees. Right? You guys agree? Okay, so we can rewrite that as sine 2 theta. The maximum value for sine 2 theta can be 1, right? Okay, guys, Okay, are you guys all good on this? Okay, now let me ask you a question. What if, like on the exam, right, I gave you a range, right, and I gave you some initial velocity, right, and then I ask you for theta. Okay, let's say on the exam I gave you r, and I gave you some velocity. So you have, I'm trying to hit that target. Okay, and I gave you that the initial velocity of the projectile is like v0. Now, if I ask you find the angle theta, how can you find it? You're going to use this equation, right? You guys agree? But what if ultimately, so sine theta, you're trying to solve for the angle that would actually make this projectile land at your desired target, right? So you try to basically solve for theta. How would you solve for theta in this case? Can someone tell me? Like if I gave you the range, right, from your initial point to where you are trying to hit. What is it?
يعني بتصير RG over V0 squared equals sine 2 theta.
Okay. So you'll solve for sine theta based on this equation, right?
على الكالكوليتر بعمل shift sign وبعمل 2 theta equal الرقم اللي معي بتصير theta equal الرقم over 2.
Okay, so sine 2 theta is going to be equal to G مظبوط times R over V0 squared. You guys agree?
Yes.
Okay, so I'm trying to find for this. Now, let's say you're trying to solve for this. Let's say this number was actually greater than 1. Right? If the range is very large, maybe your number would be greater than 1. How can you solve like 2 theta? So 2 theta will be inverse sine, مش هيك? Inverse sine of GR over V0 squared. So theta is going to be equal to this guy divided by 2, مظبوط. But what is the inverse sine of 2? Can you do it on your calculator? What is the inverse sine of 2?
المفروض error.
Okay, how can you interpret the error?
That there is something initial بالأول عطيها more movement.
شو طلعت دكتور؟ ما فهمت، ما سمعت شو طلعت، ما معي كالكوليتر هسه.
Yeah, what happens if you do like, inverse sine of 2? What is inverse sine of 2? Let's say you did the mass here, مظبوط، طلع الرقم هون 2. Sine of 2.
شو بيطلع inverse sine of 2؟
error بتعطي error.
Okay, so how would you solve that?
دكتور السكرين تبعك مش مبينة.
Oh, okay. So I think my webcam has. Okay, we're almost done anyway. So how would you interpret that, guys? Like, how would you solve that?
هي الساين
ما بعمل
ما لازم تطلع more than 1.
3 باي over 2 بعمل الانجل مش باي over 2.
Yeah, هي ما لازم تطلع more than 1. But what if like you're on the exam, right? You're on the exam, you're trying to solve this, and now you're trying to find the angle, right? But based on that angle, you find that you're getting basically an inverse sine of 2. You're getting an error on your calculator. Like, how would you move forward on the exam? I think it's back now, right?
Calculation mistake شي مطرح.
No, there is no calculation mistake. I definitely gave you this number. I gave you this number, G, I gave you this, and I gave you what is the maximum, what is the velocity of this guy. You're trying to find
initial push بالأول غير V.
What do you mean by an initial push?
Like a force, another force.
No, we're not talking about forces. Basically, we're trying to solve a kinematic problem, right? I'm telling you that you have to hit a range R with some initial velocity V0, right? And then you're trying to solve for theta, مظبوط? But then you're doing the mass, you come here, and then you're doing inverse sine of 2. These numbers become 2. Okay, what happens if you increase the velocity here? Let's say this was 2, right? What happens if the velocity was larger? What happens to this value? Does it decrease? Decrease, right? So if you keep increasing the velocity, what happens to this value? I'm sorry?
It comes close to 0.
It becomes closer to 1. مظبوط?
To 1, sorry.
So if you increase the velocity enough, you'll actually be able to solve for theta, مظبوط, or alternatively if you reduce the range, right? So what actually that means, you know, I was hoping someone would be able to explain that to us. So basically it's not possible, right? So if I give you a very long range and your velocity is small, you try to solve theta, you can't solve it. There is no value for theta that will actually make this projectile reach here, because based on this velocity, you basically will be here, right? Even at 45 degrees, you will basically be here, right? You will not be able to actually hit the range. You will, theta will become valid when your solution is valid. Okay, guys, so just so you should always try to look into the physical intuition or interpretation of your problems, right? If you can't solve theta, basically means you want to look into this, and the problem here basically is you don't have initial velocity. The initial velocity is not very high. I could give you a very long range, right? I could give you like 200 kilometers and the velocity of like 10 meters per second. It's impossible to reach that, right? So these numbers have to make sense for you to be able to get that done. Okay, guys, are we all clear on that?
Yes.
Okay, so sorry, I think Samuel has just mentioned that, and I didn't hear that basically. So I don't think anyone has said that. Okay, so we're done for today. Obviously, the lecture is going to be posted on YouTube, and that is it for today, guys. Okay.
Thank you, Doctor. Bye.
Bye now.